Welcome to Night Lesson. Relax and learn along the way.
Intro: The Search for Harmony in a Torn World, a Cosmic Symphony. Good evening and a warm welcome to our night lesson. Close your eyes and leave the worries of the day behind as we journey to a time of upheaval, mystery, and brilliant insights. The late 16th and early 17th centuries were an era when Europe was torn by religious conflicts, and the sky was still a book of undeciphered signs. Humanity was fumbling in the twilight between medieval faith and burgeoning reason, uncertain of the boundaries between the known and the unknown. Old knowledge was questioned. New instruments promised answers, yet every discovery also held the potential for theological and social conflict. It was the time of the 30 Years' War, the plague, persecution, and deep-seated superstition, which often took the cruelest forms and plunged people into fear and terror. Science wrestled with dogmatism, and the Church saw any deviation from established doctrine as heresy. But amidst this chaos, in a world that seemed on the brink of an abyss, a man arose whose unshakable faith in the order of the cosmos led him to discoveries that would forever change human understanding of the universe. His name was Johannes Kepler. He was a figure of apparent contradictions, a hinge between the Middle Ages and the modern era, a brilliant mathematician and a deeply devout mystic, an imperial astronomer and astrologer who took his astrological duties seriously, but always sought to understand them on a rational basis. But he was also a profoundly human being, beset by personal tragedies, financial hardships, and the constant pressures of his time. Our story is not one of dry formulas and abstract theories, but of a lifelong, almost obsessive quest for the harmony of the world, that hidden order he believed he could discern throughout the entire cosmos. It is the journey of a mind that deciphered the mysterious choreography of the planets and uncovered the laws of their motion, a feat that finally caused the geocentric worldview to collapse. All this happened while he had to fight on Earth for his own mother's life in a vicious witch trial, a struggle that pushed him to the limits of his physical and mental strength. It is also the story of an early visionary who dreamed of journeys to the moon and redefined light through his optical discoveries, whose ideas often reached far beyond the horizon of his time and laid the seeds for future scientific revolutions. Let us now immerse ourselves together in this fascinating world, into the life of a man who dared to rethink the universe. Breathe in deeply, feel the calm spreading within you, and listen to the soft cosmic melody that Johannes Kepler was the first to hear and capture in mathematical notes, a melody he regarded as God's symphony. Chapter 1: A Childhood in Shadow and the Call of the Heavens. Our journey begins in the year 1571 in the small town of Wilderstadt, a free imperial city in Swabia. It was a time of upheaval, marked by the aftershocks of the Reformation and the ever louder drums of the 30 Years' War, which would soon shake the foundations of Europe. In this turbulent era where superstition and dogma often overshadowed reason, Johannes Kepler was born into a family marked by poverty and instability. His father, Heinrich Kepler, was a mercenary, a man whose life was defined by wars, alcoholism, and repeated absence. He frequently left the family for military service, went to war in the Netherlands, and eventually never returned. His mother, Katharina Guldenmann, was an herbalist and healer who lived on the fringes of society in an age when the line between natural healing and witchcraft was dangerously thin. She was a quarrelsome and uneducated woman, whose temperament and reputation would later prove to be her undoing. The constant worry about daily survival and political instability shaped young Johannes's childhood. The young Johannes was a sickly child, whose physical weaknesses stood in sharp contrast to his extraordinary mental gifts. At the age of 3, he contracted smallpox, which not only left him with weak eyesight and damaged hands but also forged a lifelong hostile attitude toward the superstition often blamed for such diseases. These physical limitations were poor prerequisites for a future astronomer who would depend on precise observations, and a mathematician who needed to perform fine calculations. But where his body showed weakness, his mind was one of insatiable curiosity and exceptional strength. From an early age he was fascinated by the starry sky. At 6, his mother took him to a hill to observe a great comet that terrified the people. 3 years later, at 9, he witnessed a lunar eclipse. These early celestial events deeply marked his young soul. He was profoundly moved by the sublime beauty and apparent order of the universe, and began to develop a childlike reverence for the hidden laws that seemed to govern the firmament. These early formative moments sowed the seed for his lifelong search for cosmic harmony. Despite the poor circumstances and the frequent absence of his father, who rarely cared for his son's education, the family enabled him to attend school, a privilege that was anything but a given for a boy of such humble origins in that era. His exceptional talent for numbers, his razor-sharp logic, and his keen observational skills quickly became apparent. This undeniable genius paved the way for a scholarship, a grace from the Duke of Württemberg, which opened the doors to the Maulbronn Monastery School, and finally to the renowned University of Tübingen. Here he was to study theology, for he was a deeply devout young man, a staunch Lutheran who firmly believed that the world was a divine masterpiece, created according to precise mathematical laws. For Kepler, science was not a contradiction to faith, but the path to understanding God's creation. In Tübingen, he met Professor Michael Masslan, one of the most brilliant astronomers of his time, who was among the few who not only understood but also secretly endorsed the revolutionary ideas of Nicolaus Copernicus. Officially, Masslan taught the traditional Ptolemaic model with the Earth at the center to avoid conflicts with the Church and Orthodox circles. But in secret, in smaller circles with his most gifted and trusted students, he shared his knowledge of the heliocentric system. For Kepler, this encounter with Copernicus's revolutionary idea was an intellectual and spiritual revelation. The Copernican doctrine, which placed the sun at the center and had the planets orbiting it in harmonious circles, as was believed at the time, was for him not just a scientific theory, but a confirmation of his deepest belief in a divinely given, mathematical order. This system seemed to him far more elegant, symmetrical, and thus more pleasing to God than the old, complicated, and unaesthetic Ptolemaic worldview. A vision began to form in his mind that would never let him go. The search for the harmony of the world. He was utterly convinced that the distances of the planets, their speeds, and their orbits were not random, but an expression of a deeper, mathematical, musical harmony. God, in his unshakable conviction, was the greatest mathematician, the greatest geometer, and the greatest composer, and the solar system was his most beautiful symphony. This search for the hidden cosmic melody became his life's mission, an inner calling that was louder than all the adversities and dogmas of his time. He wanted to decipher God's blueprint. Chapter 2: The Cosmic Mystery and the Call to Prague. Two worlds collide. After his studies, Kepler's path led him to the Protestant seminary in Graz in 1594 as a mathematics teacher. Here, far from the theological debates of Tübingen and in the relative quiet of his study, he delved deeper into his cosmic visions. He was not only convinced of the Copernican idea, but was inspired by the belief that a deeper, divine, geometric structure must exist, one that placed the distances of the 6 known planets at the time, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, in a harmonious relationship with each other. In 1596, while still a young man, he published his first major work, the Mysterium Cosmographicum, or the Cosmographic Mystery, a bold plea for the heliocentric system, linked with a visionary, albeit preliminary explanation for the architecture of the solar system. In this work, he attempted to explain the apparent irregularities in the distances of the planets by associating them with the 5 Platonic solids. These perfect 3-dimensional shapes, the tetrahedron, 4 triangles, the cube, 6 squares, the octahedron, 8 triangles, the dodecahedron, 12 pentagons, and the icosahedron, 20 triangles, had been considered symbols of cosmic order and perfection since antiquity. Kepler envisioned a magnificent, nested model. Around the orbit of Mercury, for example, he placed a sphere which was circumscribed by an octahedron. This octahedron, in turn, was enclosed by another sphere representing the orbit of Venus. He continued this until all 6 planetary orbits were separated by these 5 perfect Platonic solids, like nested Russian Matryoshka dolls. Each sphere defining a planet's orbit was perfectly inscribed in one Platonic solid and circumscribed by another. The model was fascinating in its mathematical elegance and beauty, and seemed to explain the observed distances of the planets with astonishing, though not yet perfect accuracy. For Kepler, this was the first triumphant step in deciphering the divine blueprint, an intellectual manifestation of the Creator. Although it was ultimately refuted by his own later discoveries, it was a brilliant, intuitive attempt to reveal the hidden geometry of the universe, and it brought him the favorable attention of the European scientific community. The most important person to take notice of him was the eccentric Danish nobleman, Tycho Brahe. Tycho, a man of imposing presence, whose nose had been lost in a duel and replaced with a conspicuous prosthesis made of gold, silver, and ivory, had built a vast observatory, Uraniborg, on his island of Hven. There, for decades, he had measured the positions of the stars and planets with the naked eye, achieving a precision previously unmatched. His observational data, collected in an age before the telescope, was the greatest scientific treasure of its time. A veritable gold mine with the potential to revolutionize cosmology. When a dispute with the Danish king forced Tycho to leave his island, he became the imperial astronomer at the magnificent but eccentric court of Rudolf II in Prague, and invited the young, ambitious, and promising Kepler to become his assistant. He recognized Kepler's mathematical genius, but secretly hoped that Kepler would mathematically substantiate his own complex Tychonic world model. The collaboration of these two giants of astronomy was complicated and tense from the start, an explosive mixture of egos, different working methods, and worldviews. The loud, imperious, aristocratic, and jealous Tycho, who sat on his vast treasure of data and guarded his observations like a state secret, faced the modest, introverted, but equally stubborn and intellectually unyielding Kepler. Tycho was extremely suspicious, and released his painstakingly collected observations only in small portions. He feared Kepler might steal the fame he had earned through a lifetime of meticulous work. Tycho himself believed in his own complex world model, a so-called Tychonic hybrid system, in which the Sun orbits the Earth, while all other planets orbit the Sun. He hoped Kepler would provide the mathematical proof to confirm his model. Kepler, on the other hand, was aware of the inestimable value of Tycho's data. He knew that without these precise observations, especially those of the notorious orbit of Mars, he could never prove or disprove his vision of cosmic harmony. Mars, with its apparently irregular and enigmatic path across the sky, was a persistent problem that troubled all previous models, both Ptolemaic and Copernican. Tycho assigned Kepler the task of solving the riddle of Mars's orbit, perhaps also hoping to keep him busy with this notoriously difficult task. Tycho is said to have mockingly claimed that Kepler would solve it in 8 days. He had no idea that it would cost Kepler 8 years of the most intense mental labor, a tenacious struggle, an intellectual war over the Mars data, as Kepler himself called it. When Tycho Brahe died under mysterious circumstances in 1601, legend has it from a ruptured bladder because he was too polite to leave a royal banquet, while other theories suggest urinary retention or even mercury poisoning, which could not be ruled out afterward. Kepler succeeded him as imperial astronomer and mathematician at the court of Rudolf II. This position brought him prestige, but only an irregular salary. Yet the battle for the data was not over. He had to negotiate long and hard with Tycho's heirs, who considered the data treasure family property and guarded it jealously. Only after a persistent legal dispute which further strained Kepler's already tight financial situation and affected his health, did he finally gain full access to the precious observational data of the planets. Now, at last, his great personal battle with Mars could begin, a battle that would test the limits of his intellect, his patience, and his endurance, and would ultimately change the worldview forever. Chapter 3. The Elliptical Revolution. Kepler's laws and the fall of the celestial spheres. The following years in Kepler's life were marked by an almost inhuman effort and a deep intellectual crisis, the likes of which few scientists have ever experienced. Kepler was a child of his time and, like all scholars before him since antiquity, was firmly convinced that the planets must move in perfect circles. The circle was considered the divine, flawless shape, the symbol of perfection, and the eternal, unchanging order of the cosmos. Since Plato and Aristotle, it had been unthinkable that celestial bodies could follow paths other than circles. as this would have questioned divine perfection and shaken the foundations of the worldview. It was a deeply rooted philosophical and theological conviction, inextricably linked with cosmology. Again and again, Kepler tried to force the positions of Mars, recorded by Tycho, into a scheme of circular orbits. He filled nearly 900 densely written folio pages with meticulous calculations, thousands of additions, subtractions, and multiplications, performed without the advantage of logarithms or modern calculating machines. Day and night, often to the point of complete exhaustion, he checked his work countless times. But time and again, he encountered a tiny but persistent discrepancy between his circular models and Tycho's observations. 8 arcminutes. A tiny angle in the sky, equivalent to just a quarter of the apparent diameter of the moon, barely perceptible to the naked eye. Any other astronomer before him would have dismissed this small difference as an unavoidable measurement error, an insignificant inaccuracy. But Kepler knew how precise Tycho's data were. Data obtained in an age without telescopes, a masterpiece of observational astronomy, and his deep intellectual conscience, his relentless search for pure truth, would not allow him to ignore this small but crucial discrepancy. He later wrote in his epical work, Astronomy Nova, that upon these 8 arcminutes he would build a new astronomy. It was an act of courage, a departure from the comfort zone of millennial-old dogmas. This moment of acceptance, that his previous assumption, and thus the entire established cosmology, had to be wrong, was the true turning point of his scientific career, and a milestone in the history of science. It was a heroic act of intellectual freedom and scientific integrity to break away from such a deeply rooted idea, even if it contradicted his own aesthetic and theological beliefs. In this deep crisis, he discarded the 2,000-year-old doctrine of the perfect circular orbit. He tried another shape, the ellipse, a squashed circle, a geometric figure that had until then been dismissed as imperfect and considered unsuitable for celestial movements. And suddenly, everything fit, like a key that, after a long, arduous search, slides into a complex lock. Tycho's observations fit perfectly into an elliptical orbit. The departure from the circle was not just a mathematical correction. It was a philosophical and theological revolution that forever ended the idea of a perfect, immutable celestial sphere and paved the way for a more dynamic, mechanistic understanding of the universe. From this years-long, arduous, and often frustrating work, which he described as his war against Mars, he finally formulated his famous 3 laws of planetary motion, which would change the worldview forever. Kepler's first law, 1609. The planets do not move in circles, but in ellipses. The Sun is at one of the 2 foci of each of these ellipses. This meant that the Sun was no longer at the exact center of a perfect orbit, but slightly offset. It was a radical departure from the ancient notions of symmetry and perfection that Copernicus's heliocentric system had still retained. Now the Sun was no longer the geometric center, but the dynamic focus. Kepler's second law, 1609. A planet moves faster when it is closer to the Sun and slower when it is farther away. Kepler found that the line connecting the Sun and a planet sweeps out equal areas in equal intervals of time. Imagine you are coloring in the area the planet covers in a month. Whether it is close to the Sun and fast or far away and slow, the colored area is always the same size. This replaced the ancient idea of uniform circular motion with a new, dynamic and variable harmony that elegantly connected speed and distance. Kepler's third law, 1619. This law, published in his magnum opus, Harmonices Mundi, revealed an even deeper, universal order. It states that the square of a planet's orbital period is proportional to the cube of its semi-major axis, which is its average distance from the Sun, expressed mathematically. T squared tilde a cubed. This law connected all the planets in a single grand mathematical framework, showing that the entire solar system followed a single universal law that transformed apparent complexity into beautiful simplicity. These 3 laws were a revolution of immeasurable scope. For the first time, they described the actual motion of celestial bodies with a mathematical precision that was previously unattainable. The sky was no longer an impenetrable mystical realm that operated according to inscrutable divine whims. It was a gigantic clockwork, a machine whose laws could be understood, measured, and calculated. Kepler had not just collected data or proposed theories. He had found the score of God's symphony and written it in a language that all of humanity could read, mathematics. His laws provided concrete proof for the Copernican system and formed the unshakable foundation for modern astronomy. Chapter 4 Shadows over the Scholar. The witch trial and personal dramas. While Kepler was deciphering the eternal laws of the cosmos and revealing celestial mechanics, his own life on Earth was ravaged by a chain of merciless blows of fate and the relentless chaos of his time. The 30 Years' War, a devastating conflict that laid waste to large parts of Europe, depopulated entire regions, and plunged society into anarchy, formed a grim backdrop for his intellectual work. At the same time, the plague raged, a relentless scourge that wiped out entire families and kept daily life in constant fear of death. Amidst these global catastrophes, Kepler had to fight not only for his own survival, but also for that of his family. He experienced the death of his first wife, Barbara, who died of a fever, and of several of his beloved children, who fell victim to the plague. Each loss was a deep wound that hit him hard as a profoundly emotional person. He himself often lived in poverty, as his salary as imperial mathematician at the court of Rudolf II and later Ferdinand II was notoriously paid irregularly, if at all. This constant financial insecurity, coupled with political and religious turmoil, forced him to move repeatedly, uprooting his family and painstakingly building a new life. Cities like Graz, Prague, Linz, Sagan, they were stations on his odyssey, always in a desperate search for a place where he could conduct his research in peace and fathom the beauty of the cosmos. But the greatest and most painful trial, an episode that drastically illustrates the oppressive contrast between his scientific genius and the dark superstition of his time, was the witch trial of his own mother, Katharina Kepler. It happened in 1615 in his homeland of Württemberg, then a center of witch persecution in the Holy Roman Empire, where suspicion and fear easily led to deadly accusations. Katharina was already an elderly woman, around 70 years old, an herbalist, uneducated but sharp-tongued and quarrelsome, qualities that could quickly become dangerous in a village steeped in superstition and hysteria. After a dispute with a neighbor who accused Katharina of bewitchment, she was charged with witchcraft. This was no trivial matter, but an accusation that in that era almost always led to death by burning at the stake. The accusations were absurd and cruel. She had caused illness by touch, transformed into a cat at night to cause harm, poisoned her neighbors, and caused the death of livestock and children through magical rituals. Imagine the hysteria that spreads through a small village when fear, envy, and superstition take over, and an old woman becomes a scapegoat. Katharina was arrested, put in chains, and imprisoned for 14 months in a cold, damp tower dungeon, always under the terrible and omnipresent threat of the painful questioning. Torture. When Johannes Kepler received the news, he dropped everything. The man whose mind was at home in the vastness of the solar system, discovering the universal laws of motion, traveled across war-torn Germany to confront the superstitious and narrow-minded accusers in his hometown. For over 6 years, from 1615 to 1621, he dedicated a large part of his time, his scarce money, and his entire intellectual energy to his mother's defense. He wrote pages of detailed legal briefs, analyzed witness testimonies, collected counter-evidence, and refuted the absurd accusations point by point with the same relentless logic and meticulousness with which he calculated the orbit of Mars. He meticulously explained how supposed miracles and curses could have natural causes or be explained by chance. This incredible contrast is at the heart of Kepler's human tragedy, and testifies to his deep loyalty. With one hand he wrote his groundbreaking works on celestial harmony and the motion of the stars. With the other, a 128-page defense plea to save his own mother from certain death at the stake. He, the man of reason and mathematical proof, had to fight against rumors, hysteria, and deep-rooted superstition, against a dark side of human nature that he abhorred. Chapter 5 Inventor, Visionary, and Dreamer. The many facets of a genius beyond his monumental astronomical works that forever changed the understanding of the heavens. Kepler's mind was a tireless wanderer, constantly in motion, exploring a multitude of other fields of science and beyond. He was not just a theoretical genius who thought abstractly about celestial harmonies, but also a brilliant practical inventor and a visionary whose thoughts were often far ahead of his time, a true Renaissance scholar in the best sense. He made fundamental contributions to optics, a field that was just emerging with Galileo's invention of the telescope, and was set to revolutionize astronomy. Fascinated by the workings of the human eye and the new optical instruments, he meticulously studied how light is refracted by lenses and how images are formed. In his 1604 work, Ad Vitellinum Paralipomena, supplement to Whitello's Optics, he was the first to propose a correct, physically based model of the human eye, understanding that the eye focuses light onto the retina to form an inverted image and that the brain must correct this image to allow for upright perception. He not only explained how eyeglasses correct nearsightedness and farsightedness, but also designed an improved version of the Galilean telescope, the so-called Keplerian telescope. This used two convex lenses and produced a brighter, sharper, and upright image that became the standard for astronomical observations throughout the 17th century. His work was groundbreaking and still forms the basis of modern optics today. He saw the telescope not just as an observational tool, but as an extension of the human mind to reveal the wonders of creation. His eye for hidden patterns and orders in nature was insatiable, extending even to seemingly trivial everyday phenomena. On a cold winter day, he observed a snowflake that had landed on his coat and was fascinated by its perfect unchanging six-sided symmetry. While always six corners, never 5 or 7, this seemingly simple question led him to a deep investigation into the densest packing of spheres, a treatise he published in 1611 as Strina seu de Nive Sexangula, a New Year's gift, or on the six-cornered snowflake. He recognized that the hexagonal arrangement, as used by bees in their honeycombs, is the most efficient way to fill a surface with circles, and he suspected that this must also apply to the packing of spheres in three-dimensional space, a conjecture now known as the Kepler conjecture, which was only fully proven mathematically in 1998, almost 4 centuries later. An elegant solution to a seemingly trivial everyday problem that underscores Kepler's deep understanding of geometry and order in nature. But perhaps his most astonishing and personal work was a narrative called Somnium, Latin for the dream, a work that reached far beyond the boundaries of astronomy. It is widely recognized as one of the world's earliest works of science fiction and a bold vision of an interstellar journey. In this fantastical tale, which he began in his youth and refined over many years, he describes a journey to the moon, carried by demons who serve as allegorical guides to another world. But what begins as fantasy turns out to be a brilliant scientific treatise. From the perspective of a moon dweller, Kepler describes in detail what the Earth would look like from the sky, a huge motionless disk that slowly rotates and goes through phases, just like the moon as seen from Earth. He describes the harsh temperature fluctuations on the moon, the thin atmosphere, and the altered gravity. In a brilliant way, he uses the fictional journey to reflect on physical concepts like inertia, the vacuum of space, and gravitation outside of an earth-bound frame of reference, concepts that were far ahead of his time. Kepler used the form of a dream to present revolutionary scientific ideas that he could never have published in a direct treatise, without exposing himself to ridicule or heresy. Tragically, this very fantastical story was used in the witch trial against his mother as proof that she had taught him the secret arts of moon travel and was herself a witch. Thus, in Kepler's life, science, mysticism, and drama merge in a unique and often tragic way. Chapter 6, Harmonices Mundi, the harmony of the world and the Creator's blueprint. Despite the countless blows of fate and the external turmoil of his life, Johannes Kepler never lost his unshakable faith in an orderly, harmonious world. On the contrary, this deep-seated conviction strengthened him in his scientific mission. His greatest dream was to consolidate all his discoveries, his mathematical laws, his optical insights, and his mystical visions into one great comprehensive work that would reveal the beauty and order of the universe in its entirety. This monumental work, his opus magnum, he called Harmonices Mundi, the harmonies of the world, published in 1619. It is perhaps his most personal and at the same time his boldest book. a synthesis of mathematics, geometry, music, astronomy, and theology, in which he attempted to decipher God's fingerprint in the cosmos. Here, he not only introduced his groundbreaking third law of planetary motion, but also completed his lifelong search for the cosmic melody, the harmony of the spheres. This concept, which Pythagoras had already postulated in antiquity, was radically reinterpreted by Kepler. He did not believe in a physically audible sound in space produced by floating crystal spheres, as the ancient Greeks did. His music was an intellectual harmony, a celestial music perceived not with the ears, but with the mind and soul, an abstract music that reflects God's geometric blueprint of the universe. For Kepler, mathematics was the language in which the Creator had written the universe, and music was the way these mathematical relationships were perceived by the soul. The key to this music lay in the speeds of the planets. According to his second law of planetary motion, each planet moves at different speeds in its elliptical orbit, fastest when it is closest to the Sun, perihelion, and slowest when it is farthest away, aphelion. Kepler meticulously calculated the angular velocities of each planet at these two extreme points, as seen from the Sun. The ratio between these two extreme speeds, he brilliantly realized, corresponded exactly to the fundamental intervals of music theory as it was understood at the time. He compared planetary motion to musical scales and proportions. So each planet sang its own distinctive melody, a musical interval that reflected its eccentricity, that is, its deviation from a perfect circular orbit. Saturn, majestically slow at the outermost edge of the known solar system, moved relatively leisurely. The ratio of its speeds corresponded to a major third, a 4:5 ratio, like the first two notes of a major chord, a deep, calm sound. Jupiter sang a minor third, 5:6, a slightly more melancholic but still harmonious sound. Mars, the red warrior planet, had a significantly more eccentric orbit and therefore sang a larger interval, a perfect fifth, 2:3, one of the most powerful and fundamental harmonies in music, often symbolizing strength and determination. The Earth sang a very small step, a semitone, from Mi to Fa, 15/16. Kepler interpreted these notes as an abbreviation for the Latin words miseria et fames, misery and famine, a melancholic but realistic description of the state of the world plagued by the 30 Years' War. Even in the celestial song, there was an echo of earthly suffering. Venus, whose orbit is almost a perfect circle, barely sang an interval, just a tiny step of 24/25, almost a constant tone, a symbol of its nearly perfect, gentle motion. And nimble Mercury, which raced fastest around the Sun and had the most eccentric orbit, covered the largest interval of all with its song, a major tenth, an octave plus a major third, a rapid, almost ecstatic sequence of notes that reflected its fast and restless movement. Kepler imagined the planets as a celestial choir, working together in perfect harmony. Saturn and Jupiter formed the deep basses, Mars the strong tenor, Earth and Venus the gentle alto voices, and Mercury the nimble soprano. He was convinced that there were extremely rare moments, perhaps only at the instant of creation itself, when all the planets sounded together in perfect universal harmony. It was a silent mathematical symphony of the solar system, a symphony that was not heard but understood, the ultimate representation of divine order and beauty. For him, this was proof that the universe was not a chaotic accident, but a masterpiece of divine art. This work, the Harmonices Mundi, was the decisive step that made everything else possible. Kepler provided the precise description of how the planets move. His laws were not just theoretical constructs. They were the empirically proven rules that governed the entire solar system and ushered in a new age of physics. The next generation of scientists, foremost among them Isaac Newton, could now turn to the question of why they move that way. Newton's universal law of gravitation, which explained the motion of apples on Earth and planets in space, would have been unthinkable without Kepler's three laws. Kepler had written down the score of the celestial clockwork, the notes and rhythms. Newton provided the explanation for the invisible mechanism, the force that drives it, the fundamental physics behind it. Kepler died in Regensburg in 1630 while trying to collect outstanding salary payments, poor and in search of financial security. A tragic end for such a brilliant genius. His grave was later destroyed in the chaos of the 30 Years' War, and his mortal remains were lost, but his legacy remained immortal. When we look through a modern telescope today, understand the elegant orbits of the planets, or admire the images of distant galaxies, we stand on the shoulders of this extraordinary man, a man who, under unimaginable difficulties, never lost sight of the true order of the cosmos. His search for harmony is a quiet, calming echo that reaches us through the centuries. It invites us to find peace and marvel at the silent beauty of the starry sky, the order that Kepler was the first to perceive in its mathematical purity, and which inspires us to this day to continue deciphering the secrets of the universe. Outro: A Light in the Darkness. Kepler's eternal legacy. Johannes Kepler's life was a constant struggle between light and shadow, an odyssey through a world torn by contrasts and sinking into the turmoil of religious wars and epidemics. The brilliant light of his genius insights, which reordered the celestial canopy and redefined the cosmic order, was contrasted by the dark shadow of war, disease, and the absurd superstition of his time, which almost cost his mother her life. Yet he was never deterred. In a chaotic world marked by instability and suffering, he found the eternal mathematical harmony of the stars. Driven by his deep faith, his unwavering hope, and his boundless curiosity, he gave humanity a new universe, one governed not by divine whim, but by elegant, immutable mathematical laws. He revealed the mechanics of the heavens and proved that creation could be grasped in numbers and proportions. A tool for reason, not for blind faith, his life is a shining example of the persistence and triumph of the human spirit in the midst of adversity, proof that the thirst for knowledge is unquenchable. It reminds us that even in the darkest of times, the unconditional search for knowledge and truth is an indestructible force that can overcome dogmas, dispel superstitions, and trigger intellectual revolutions. It shows us how a single person, endowed with extraordinary intelligence, infinite patience, and the unwavering courage to break away from centuries-old established dogmas, could not only revolutionize the worldview of his time but also lay the foundations for all of modern natural science. Kepler taught us that even the most complex phenomena of the cosmos can be understood through persistent observation, precise measurement, and mathematical analysis, and that beauty lies in order. Now, let these thoughts about the heavens, harmony, and the infinite persistence of the human spirit come to rest within you. Let them gently accompany you as you drift into a deep, peaceful sleep. Secure in the knowledge that above us, a silent, wonderful clockwork follows its eternal paths, whose secrets Johannes Kepler was the first to dare to decipher, giving us an invaluable insight into the divine order of the universe. Good night. That was today's night lesson. Thank you for listening. If you'd like to see more videos like this, please leave a like and subscribe to the channel. Good night and sleep well.